Here's part 192, line 18d Carnot Thermodynamic Cycle Heat Engine TS diagram, Brayton ICECUBE 5G Wow Seti. Here's the alien radio signal, and here's a quote from Wiki. The Carnot cycle is a theoretical thermodynamic cycle proposed by Nicholas Leonard Sati Carnot in 1824 and expanded by Benoit Paul Emilius Clapeyron in the 1830s and 40s. It can be shown that it is the most efficient cycle for converting a given amount of thermal energy into work, or conversely creating a temperature difference, e.g. refrigeration, by doing a given amount of work. Every thermodynamic system exists in a particular thermodynamic state. When a system is taken through a series of different states and finally returned to its initial state, a thermodynamic cycle is said to have occurred. In the process of going through this cycle, the system may perform work on its surroundings, thereby acting as an heat engine. A system undergoing a Carnot cycle is called a Carnot heat engine, although such a perfect engine is only a theoretical limit and cannot be built in practice. The Carnot cycle, when acting as a heat engine, consists of the following steps. It has reversible isothermal expansion of the gas at the hot temperatures. The gas expansion is propelled by absorption of quantity. The isentropic expansion of the gas, and then it says the piston and cylinders are assumed to be thermally insulated. The gas continues to expand. The reversible isothermal compression of the gas at the cold temperature. Isentropic compression of the gas. So again, I was talking about compression of the gas, which is one of the things that we want to do with the UFO engine. So this is showing how this equation would do it. So maybe there's a way for us to do this. So the cycle takes place between a hot reservoir at temperature TH and a cold reservoir at temperature TC. The vertical axis is temperature, the horizontal axis is entropy. There's a figure 2. A Carnot cycle acting as a heat engine, illustrated on a pressure volume diagram to illustrate the work done. And a temperature entropy diagram. This is from Wiki. A temperature entropy diagram, or TS diagram, is used in the thermodynamics to visualize changes to temperature and specific entropy during a thermodynamic process or cycle. It is a useful and common tool, particularly because it helps to visualize the heat transfer during a process. For reversible ideal processes, the area under the TS curve of a process is the heat transfer to the system during the process. An isentropic process is depicted as a vertical line on a TS diagram, whereas an isothermal process is a horizontal line. So there's the different processes there. There's the example of what it looks like on this diagram. Cycle ratio of the white area, somewhere right there, total heat. So that's US units. So my thoughts, January 25th, 2012 was when I first started working on this, and it's now April the 27th. When I saw this diagram, I immediately think of the IceCUBE Observatory deep sea neutrino tests. Now here's a turbine here with some diagrams here. This is an example of a real system modeled by an idealized process. PV and TS diagrams of Brayton cycle map to actual processes of a gas turbine engine.